in 1859, during the only solar superflare of the technological age. It's called the Carrington event. It was a massive solar eruption directed at Earth, one that set telegraph wires on fire and shocked the operators. These events are expected every 150 to 200 years. It's been 162 years since 1859. For those who have heard about Earth's magnetic field changes, the weakening protection and shifting magnetic poles, that began in 1859 as well, same time as the last solar superflare. The Sun is thought to be capable of at least 100 times stronger eruptions than the 1859 event. Now, let's go back to the last episode in this disaster series, the effects of even common, modern-day lightning. It's quite profound. We showed not only the real-world examples of lightning effects, but those from the laboratory as well. For those who know Billy's plasma lab, he's done more than a few electric geology experiments and recreated an absurd amount of earthly, lunar, and Martian topography. In the last episode, we were describing what happens if Earth's equatorial L shells are overcharged and compressed in a major solar event, resulting in cosmic discharges downward, and we went over the crater evidence in line with the cycle. And since ocean hits would be even more likely than land hits, that is also worth considering, especially since what we expect in the Sun's next cycle event, likely in our lifetimes, will be far greater than the Carrington event. That one took the field down almost to complete fieldless exposure, maybe 1 or 2 L shells left, and something bigger is going to be a very big deal, likely penetrate all the way. When it happens, we have to think large scale, just like the magnetar burst, across continental scales like this, or like this, or this. So let's go to Billy's lab and start with simple dark mode current into a water drop. Look how she moves. The stronger the current, the broader the application area of the electrode, the larger the pool of water, the more interesting things can get. But if you can make it dance, you can make it run. Water is fundamentally attracted to electric current and will be phenomenally attracted to the current of focus here in this video. I picture lake-sized bodies or larger being lifted and shifted and sent across dry regions in the blink of an eye. Just as in all of Billy's experiments, it hunts the fault line conductivity, an easiest pathway to ground. You can paint a canvas with the motions of the current, and if that canvas is our world, what happens when the lightning takes over? Some other things to consider are the forces of underground water, which Billy showed to be utterly disrespectful of gravity if the prettier arcs make themselves available, and in addition to the whipping of the surface waters at will and the lifting of the waters below to shift things about, our atmosphere is water, clouds, humidity, in addition to the winds produced by atmospheric water attraction in such an event, which will include various levels of lightning averaging on the scale of the great storms of Catatumbo, but across thousands of miles, linking the ionosphere to the ground. It will also produce cyclonic formations of unimaginable proportions. Hopefully here, we remember Billy's highlighter fluid experiment with current into the right side electrode and out the left, alternating vortices, alternating directions to the helical flow, and since everyone wanted a shot from above, he did it. And then, because he knew we were all still wondering, he took the magnet that he had placed below the water body and he flipped it upside down. And what do you know? The water spun the opposite way than it had before. But just for a moment, I want to go back to the highlighter in blue. Towards the end of the sequence, watch the electrolysis separating hydrogen and oxygen there. This is a known process that Billy has explored at great length, using current to split the gas and then combining it with everything from plasma in fire form to arc discharge sparks. The recombination explosion of pure water is absolutely crazy, and it just takes electricity for both the split and the reunion. He actually did this with a balloon outside in his yard, and if you can't read body language, this is so loud, I need to get out of here. The atmospheric vapor, the surface waters of the oceans and lakes, and the groundwater below, all moved at will by the current, taking on cyclonic patterns dependent on the strength of the electric force, and all while there may be an even scarier explosive aspect to the matter. It's an absolutely valid question to ask what such an electromagnetic insult to the Earth would do to the water. And in terms of that, the answer is very clear, even if it still requires our imaginations to apply these concepts to the rivers and rains and the oceans. I'll see you in the morning for the daily update. Be safe, everyone.